Find the charges on three capacitors connected to the battery as shown. C1 equal to 2 microfarad, C2 equal to 4 microfarad, C3 equal to 6 microfarad, and V equal to 12 volt. Clearly, C1, C2, C3 are in parallel. So we can redraw the diagram. This is C3, this is C2, this is C1, and then they all three are connected through a battery. Now, for each loop, Q equal to CB applies. So for first loop, Q1 equal to C1V. So C1 is given as 2 microfarad. So 2 into 10 to the power minus 6 into voltage is given as 12 coulomb. Similarly, for second loop, this one. So Q2 equal to C2V. So C2 is 4 into 10 to the power minus 6 into 12 coulomb. And Q3 equal to C3V. So this loop. So C3 is given as 6 into 10 to the power minus 6 into 12 coulomb. Now consider next question. Question number 7. Three capacitors having capacitances 20 microfarad, 30 microfarad, and 40 microfarad are connected with a 12 volt battery. Find the charge on each of the capacitors. How much work is done by the battery while charging the capacitor? So here, this is 20 microfarad, and this is 30 microfarad, and next one is 40 microfarad. They all three are connected to 12 volt supply. Now, since all three capacitors are in series, so charge on each will remain same. So let's find out equivalent capacitance first. So 1 upon 20 plus 1 upon 30 plus 1 upon 40. So this will give a LCM will be 120. So this is 6 plus 4 plus 3. So CS will be equal to 120 upon 13 microfarad. Now Q equal to CV. C equivalent times voltage. So it will give 120 upon 13 times voltage is 12. So if we simplify it, we will get 110.77 into 10 to the power minus 6 coulomb. Now, here, as it is clear that charge on each capacitor will remain same, so that will be equivalent to this much. Now, work is equal to energy stored in capacitors. So 1 by 2 C equivalent times V square. So 1 by 2 C equivalent we have found as 120 divided by 13 microfarad into 10 to the power minus 6 times voltage squared, voltage is 12 square. So if we simplify, we will get 1.32 into 10 to the power minus 3 joule, which is our answer. Now consider next question. Find the charge appearing on the three capacitors as shown. Here, these two capacitors are in parallel, so equivalent capacitance will be sum of the two. So it will be equal to, this is 8 microfarad, and this will also become 8 microfarad. And that is connected through 12 volt supply. Now, equivalent capacitance we can find. So equivalent capacitance will be 1 upon 8 plus 1 upon 8 is 1 upon CS. So CS will be 4 microfarad. Now, total charge Q equal to C series into voltage applied. So 4 into 12 micro, sorry, 4 into 12 into 10 to the power minus 6 coulomb. So this is total charge. So through this capacitor, charge will be this. But here, since these two capacitors have equal value, so the charge will be equally divided into two parts. So we can say on 8 microfarad capacitor, charge will be 48 into 10 power minus 6 coulomb, whereas on this fourth, it will be 24 into 10 power minus 6, and on this capacitor also, it will be 24 into 10 power minus 6 coulomb. Now, let's go to question number 9. Find the equivalent capacitance in the two cases. Here, this circuit is equivalent to these two are in parallel. So C1 and C2. Then again C1 and C2. So if we evaluate it, so this will become, here value is given, C1 equal to given as 4 and C2 is given as 6. So this will become, this portion will become equivalent to 10 microfarad, and this will also become, being parallel, 10 microfarad. Now these two are in series, so resultant will be CS will be equal to 5 microfarad. Consider this is combination of the same thing twice. So as we have evaluated this part, so we can say that upper part is 1 CS and this lower part will also be equal to same. So 1 CS, and we have got CS as 5 microfarad. So this will become, here we can write 5 microfarad. This also has 5 microfarad. So these two are in parallel. So equivalent will be, it will become 10 microfarad. This is 5 microfarad, this is 5 microfarad. So this will be equivalent to 10 microfarad because these two are parallel, C equal to this much. Now, consider next question. Find the charge supplied by the battery in arrangement shown. Here, this is 5 microfarad, this is 6 microfarad, battery is 10 volt. Clearly, these two capacitances are in parallel. So we can redraw the diagram. This is 5 microfarad and this is 6 microfarad. And then we connect this through a battery of 10 volt. So here, first of all, we apply loop rule. So for first capacitance, for 5 microfarad capacitance, Q1 equal to C1V applies. So Q1 is to be found. Q1 equal to C1 is 5 into 10 to the power minus 6 into voltage is 10. So this will become 50 microcoulomb. And for 6 microfarad capacitor, Q2 equal to C2V implies Q2 equals C2. C2 is 6 into 10 to the power minus 6 into battery is 10. So this is 60 into 10 to the power minus 6 coulomb. So here, total charge, here we have got this as Q1 and this as Q2 and this charge is Q. So Q will be sum of Q1 plus Q2. So Q1 is 50 microcoulomb and Q2 is 60 microcoulomb. So total will be 110 microcoulomb, and that is our answer. Thank you for watching.